Welcome to Tales at Scale, a podcast that cracks open the world of analytics projects. I'm your host, Rena from Imply, and I'm here to bring you stories from developers doing cool things with Apache Druid, real-time data and analytics, but way beyond your basic BI. I'm talking about analytics applications that are taking data and insights to a whole new level. And we've got one more Druid release before we say goodbye to the monumental year that was 2023. Druid 28 is already here, and as always, super big thanks to the dedication of the Druid community. This release was made possible by over 420 commits from 57 contributors. You all are awesome. Thank you so much for making this happen. Joining me once again to talk about the Druid 28 release is Will Shu, product manager at Imply. Will, welcome back to the show.
Excited to be here.
Okay, so it seems like we just had you on talking about Druid 27, and here we are at Druid 28. Let's get right into this release, starting with some of the latest updates to MSQ. One of those things was ANSI SQL support improvements. Let's start there. Can you tell me about that?
Yeah, absolutely. So a lot of people out there, they are porting their workload from one database to another database. And one thing that ensures their workload works across different databases is the SQL standard, or in the industry, people usually refer to ANSI SQL standard. Druid in itself, especially on the query engine side, is fairly compatible with the latest ANSI SQL spec. And what we are doing are some of the fundamental behavior changes to make sure the engine is more compliant with the ANSI SQL standard. And some of the changes that we're doing are around no value support, around tri-state logic, and around Boolean value support. Now, one of the things that you might know about is a lot of database treats null and empty streams differently. So something is empty isn't quite empty because, for example, a person can come in to register in a user portal, and then this person might not have a last name due to cultural differences. And this person registering there without a last name is different than, say, a person didn't register or didn't put in last name. So the database somehow needs to be able to distinguish between those two conditions. And historically, to be able to process queries effectively with good performance, now you need to check two states, whether it's empty or it doesn't exist. And that is very, very cost prohibitive in terms of running expensive queries. And the changes we've done in this release is to make us not only very standard compliant so that we can distinguish between those two different states, but also don't impact any of the performance on the query side. And so when we talk about like ANSI SQL compliant, it's ANSI SQL compliant without any performance penalty. So in this release, we have introduced the default state for Boolean values to be very strict. We have introduced the tri-state logic to properly support the no values. And then also we have turned on the no value support by default into the production state. And there's no performance penalty to do this whatsoever. So all those three things combined to basically allows us to behave very much like any other database that is ANSI SQL standard compliant without the performance penalty.
And I think one other improvement I remember from the release notes was also additional Apache Calcite support. Is that in there in this release?
Yeah, so Druid, like many Java-based databases, use a library called Calcite to do query planning. And due to various reasons, the Calcite library in Druid has been stuck on a very old version for a couple of years at this point. And that prevents us from leveraging some of the latest performance enhancements the Calcite library has introduced. So in this release, we have updated the Calcite library to the latest version. I think it's 1.35 or 1.37. And that has all the latest and great features for Calcite. So on a tangential side, you should be able to see some more performance improvements in terms of query planning. And over the course of next year, we will be adding more integration into the Calcite engine to get the most out of the library itself. So this sets up us for success for 2024, for sure.
Awesome. As I was going through, one of the things I noticed about this release is that a few experimental features have been added as well. A wish list item that we've talked about, window function. What's the latest on that?
Yeah, so window function is quite exciting. It brings us one step closer to full ANSI SQL compliant. full ANSI SQL compliance. And as part of the ANSI SQL standard, I think it's like SQL 99 or 2006, there's introduction of window function, and we are fully supporting basically all the Postgres equivalent window function features in this release as an experimental release. And what that means is for a lot of data sets where you're looking for trends or you're looking for bucket analysis for data, this becomes incredibly useful. One example I always give people is let's imagine in a world where you have sensors on top of doors within the building, and then you're counting how many people are walking through the doors. And then you want to understand across the entire day cumulatively, what is the sensor that has most people walk through the door with? And using window function, what you can do is you can bucket the people walking through the door by the sensor ID it has. And then you can say for a given sensor, say on the east side of the building, door number 2, this is cumulatively how many people has walked through the door. Because window function allows you to essentially partition your data based on some dimensions of your choice, in this case, the sensor ID, and then order the data within, in this case, at what time the person has passed this through the door, and then perform operations on top of this pre-ordered data, pre-partition, pre-ordered data. And in this case, you can basically do cumulative sum of how many people has walked through the door. It is generally very, very useful for a lot of analysis, and it's especially useful for data that people usually put into Druid, which are time series data or event data, because all those data you need some notion of partitioning or ordering for them to make sense. So not only window function we're introducing in this release makes it more SQL standard compliant, it also allows a lot of common use cases that people would rather do on Druid today.
Awesome. You know what? It's fun to like kind of see like that got mentioned, a few releases ago, and we've been doing the show for about a year now, and see where things were kind of, ideas or things being worked on, things on people's wish lists for Druid, and now to like come full circle to have them be added as an experimental feature is really cool to see. I've actually, speaking of experimental features, a few features have actually graduated from experimental to GA, like async queries and queries from deep storage. Again, query from deep storage, another wish list item. So let's kind of dive into what those look like in Druid 28. Let's start with async queries and query from deep storage.
Yeah, I'm excited to talk about this. We're finally graduating this to generally available as a feature. Async queries and querying from deep storage really allows you to run queries in a task engine mode that's separated from the Druid current regular query engine mode. And the way it works is you issue a query without having the data to be preloaded or pre-cached. If your data, say, like sits somewhere in the S3 storage bucket, and you're only querying this data once a week or once a month, you don't necessarily want to pay for the ongoing storage and compute cost for it. We can spin up compute resources on demand and then query those data and then spin those resources down. It's an extremely cost-effective way for querying data. And it's very, very useful if you have, scheduled reports, like download workloads, where, people are accessing data infrequently. And if you look at the other piece of feature that was built into the Druid engine itself in the past few releases is the native Kubernetes integration. The native Kubernetes integration allows you to spin up pods in Kubernetes on demand and then spin them down without having any persistent resources running. So in this case, if you issue a asynchronous query, the asynchronous query will spin up the Kubernetes layer automatically, find the compute resources, do the computation, spin them down, and give the resources back. So it's extremely, extremely cost effective for infrequently accessed data. And in this release, what makes this GA is now it supports a proper resolving format. That means if you're downloading, hundreds of gig of data out of Druid, it's not going to crash and burn because everything is bottlenecked on a single node. The system now is designed to handle really, really, really large scale result set. And it has a lot of other redundancy, a lot of fault tolerance built in to make it function well in various cloud environments. So those are the things that we've been doing in the background and since the last release in the last 3 months. And then at this point, we're pretty comfortable that you can use this well in production kind of scenarios. And please, do try it out. Let us know.
Well, also I should mention, like, kind of the way that we're talking about this release is like a lot of these things work together, right? And like build upon each other to like make a better Druid. On that note, I'd like to talk a little bit more about arrays actually, because I know that was another thing that was improved upon in this release.
Yeah, for sure. So as if you listen to the previous podcast, we've talked about we have made auto type inference schema discovery ingestion. It's a mouthful to work. What that means is if you have data with complex data in that, we'll auto load everything without you having to tell us like what the data shape looks like, which is great, right? So if you have some random database, you're like, let's load this into Druid to accelerate it. Easy, right? Just like, select start into Druid and you're done. And we auto figure out the right typing for like all the columns, if it's a number, if it's float, or it's like a string or whatnot. But one of the things that's like very, very tricky, what we found is handling arrays. What that means is if you look at a lot of common data out there, social media, for example, for every single post or picture you post, there's a bunch of hashtags. The list of hashtags you have is essentially an array. Or if you look at like e-commerce data and then each order that user submits, very, very commonly there's more than one item the user is ordering. And then that is an array. Druid historically has a lot of issues and challenges on handling arrays because going all the way back to today, the start of today's episode, we talked about, ANSI SQL standard compliant is treating empty and non-existent is very, very different. So let's say I ingested some order data. The order data has like no item in it. Is it because the user has submitted a order without a item? Or is it because the user submitted a order where the item's name is empty? And now we're able to distinguish between all those scenarios correctly so that your existing data can be ported very, very easily into Druid. And that makes the whole like onboarding and data discovery experience super easy. And if you are a platform owner, you're looking for like integration to say like, how do I put Druid into my overall platform workload without a lot of effort? This is one of those features that's going to make your life super easy.
Another, while we're kind of talking about, things that have gone to GA and additional support, SQL and Nest, I believe, went GA in this release. Is that correct?
Yes. SQL Nest went GA in this release as well. SQL Nest historically has been used for dealing with, precisely array data, which is what we've just talked about. If you have a bunch of array data, how do you analyze it, right, in the query? And Nest basically allows you to, as the name suggests, nest the array data and then flatten them into a bunch of rows so that you can do normal operations on them. And then shipping the array discovery in this release as a generally available feature, as well as the nest as a generally available feature, basically put things together to allow you to auto discovery, auto ingest, and easily analyze array data, which is like, out there is a very, very common shape, like in everyday real world scenarios. And then all those things accumulate together in this release to make that experience good for people who want to analyze those kinds of data.
Another cool feature worth mentioning actually is multi-topic Apache Kafka ingestion, because it kind of removes the need for dedicated resources in Druid to consume low traffic topics or accept, higher ingestion latency to spin up tasks on demand. So how does that exactly work in Druid 28?
Yeah, so let's talk about like streaming ingestion, right? A little bit.
Mm-hmm. Love that topic. Love that well.
Yeah, absolutely. Streaming.
We talk about it a lot.
is the bread and butter for Druid. A lot of people use Druid for the purpose because it supports you to query data that's coming from Kafka or Kinesis or like other streams directly. And one thing that we've noticed over time is a lot of organization as they start adopting Kafka as like a streaming platform, they have a few very, very big and very busy topics where majority of their business data are coming through. But there are a lot of cases where people are seeing lower volume topics in their Kafka environment. Some of them goes to the extreme to say like 1 or 2 events a day as a topic. Now, Druid originally was designed as a system to maintain really low latency. So that means, if your event goes into a Kafka, it will be ingested into Druid almost like instantaneously and made available for querying. To maintain that kind of latency, Druid needs to basically run a process 24/7 to monitor the Kafka topic as events come in. And then as the events come in, Druid immediately picks it up and then spin this out for doing query. But keeping a process up and running 24/7 for a topic where 1 or 2 events happen a day is very, very expensive. It's very cost prohibitive. You're essentially wasting a CPU core for majority of the day, which are super expensive. So what can we do in this case, right? One option is we can spin the process down, monitor something, and then spin something back up. That introduces a lot of latency. That means Druid is no longer responsive as a real-time system. That's not very useful. So instead, what we're thinking about is, what if we combine all those low volume topics together? So basically, instead of ingesting 1 topic, 1 event per day, you're looking at 1,000 topics, and each of them has like 1 event a day. And now that's like a substantial amount of traffic in aggregate to make it worthwhile for you to spend like a CPU core monitoring all those 1,000 topics together. And this is what the multi-Kafka topic ingestion is about. It effectively takes a regex expression as the topic name. So anything that we can detect as a topic name, we can start loading data from. And then you can combine a bunch of low traffic topics together into a single ingestion task. And then the output can be written to a single destination with a way for you to tell apart like where topics coming from. And what's cool about this is because not all topics have matching data schema. You will have different data shapes going into different topics. And if you remember from the last time, we have introduced a feature for schema auto discovery. That means, if you don't specify schema, we can auto discover the shape of your schema. And then in this release, we have introduced the auto discovery of arrays. So if you combine multi-Kafka topic ingestion together with schema auto discovery, now you can combine mixed content with mixed topic into data sources, where it allows you to do analysis very, very easily. So this is how things are like fit together to give you a much lower cost floor, if you may, for ingesting really complex data set in the enterprise setting.
Oh, you know what? This actually reminds me of one other thing that was in this release when we're speaking about, streaming ingestion and query performance is concurrent append and replace. That's experimental, but that was added in this release, right?
Yes, absolutely. So as you are thinking about this, right? So Druid is a immutable OLAP data warehouse. What that means is everything is optimized for querying. The way I sort of like usually explain this to people is, imagine Druid as like a giant engine that does zip files. If you're familiar with zip files, you have like 1,000 tiny files, and then you're like zipping all the files together. And by default, let's say you have 1 zip file per day. You have one for Monday, you have one for Tuesday, you have one for Wednesday, etc. And then when you query them, we unzip your file, we make it very, very fast to like process the data because these files are tiny compared to the raw data itself, which is great, right? Now, what if today is Friday and then you suddenly started having people coming in to say, like, we have some data that just came in on Friday that's supposed to be in Monday. This is a very, very common phenomenon in any kind of like real world applications. People who return some stuff after they order, right? Or people who change their minds, or data needs to be like reconciliated. You always have late arrival data. It's a very, very common phenomenon. So how do you deal with late arrival data? Basically, you have to unzip the file on Monday, put all the new files together with the old files, and then rezip it together. And as you can imagine, like doing this for every single tiny file that's arriving is very cost prohibitive. And it's near impossible because you constantly might have like files arriving. What if like in the process you're trying to like revisit the files, some new data has landed, right? And this is what this feature is about, like concurrent compaction with ingestion or concurrent compaction with like appends, which is like we will take care of the handling of this complex scenario where you have like data arrival data coming in on a constant basis. You're also trying to like unzip and rezip the file so that the query performance is like very efficient. The experimental nature of this feature means there's still a lot of issues with it right now. There are certain scenarios where it doesn't quite behave well. We're going to be continue invest into this and then come back to us, in the next release. Obviously, we will be talking more about this feature. By the time that we make this generally available, what this will do is ensure the data files you have within Druid are always optimized in the shape where it has no fragmentation, and then your query performance is really, really, really good. And it also will allow you to have streaming ingestion coming in the same way as any other jobs you are doing data processing within Druid while we're optimizing the file format. And that's sort of the underlying nature of the feature. And this goes back to the original topic of like everything fits together. If you're using Kafka topics, streaming ingestion, you will have data from multiple topics arriving at different time intervals, and then they will have a lot of different dates where the data are landing, and then they will always be like late arriving, and then you will end up with like fragment data. But with this feature, essentially you will have your data in a much more optimized shape because we can operate on them while they're like still landing, and now you have like really good query performance. Even if you're using this like multi-topic ingestion.
I'm trying to think about all like the major points of this release. I feel like we've covered most of them. I mean, unless you want to kind of talk a little bit. I guess the last one's kind of Union All. That was in this release as well.
Yeah, so Union All is a very unique thing out of all the features we've talked about. In the past, if you want to do any kind of query across different data sources in Druid or any other databases, for a matter of fact, to use this feature called SQL Union All. It basically does a combination of the tables so that they feel like as if it's like a single table. Now, what if you have one table missing a column in this combined version, right? Historically, Druid doesn't behave well, basically. It basically says, sorry, you cannot combine those two tables because one of them is missing a column. But that's sort of like an unrealistic expectation in the real world because when we're combining tables, there will always be missing columns. So what this feature does for this release, the MSQ Union All, under the hood actually supports ability for you to query a bunch of tables together, even if there's missing columns, and then be able to like use them for reindexing purposes. And what that means is you can now use this feature as a way for merging multiple tables together as a single ingestion job. And it's super, super useful if you have a bunch of tiny tables you're trying to merge together.
Yeah, we've been talking about Union All in relation to like Union All unions versus like joins when it comes to Druid and how to kind of negotiate those or navigate those within how Druid works.
Yeah.
But what I was going to say is like it's kind of funny. So we're coming to the end of the year. I feel like I'm the ghost of Druid past, present, and now let's talk about future because this is our last release of 2023. But we already are kind of looking ahead into what's going to happen for Druid in 2024, which at the time of this release is like right around the corner. How is the roadmap shaping up for the next release? And by the way, folks, this will be public. Will, what can you tell me about that?
Yeah, so we are in the midst of like coming together with the community's input. What will be the roadmap look like for Druid for next year? If you're interested, please do keep an eye on the Apache/Druid GitHub repo. We will be posting the draft as well as the final version of the roadmap there sometime in the January-February timeframe for 2024. And then that will be the baseline for what we'll be working towards against for the next year.
Will, I think we've kind of covered all like the major points for Druid 28. This has been great.
Yeah, I'm super excited, for shipping this release together with the help of the team. And then we will be continue working towards more future releases with the community.
29 and 30 coming up in the new year.
Yeah, absolutely.
Awesome. Well, thank you so much for coming back on the show and joining me today. So to learn more about Apache Druid, head over to druid.apache.org or over to the Imply Developer Center at imply.io/developer. And if you're interested learning more about what we're up to read Will's amazing Druid 28 release blog, visit imply.io. And until next time, and until next year, keep it real.